So let's solve this problem, which is named as count some matrices with all ones. Given an m cross n binary matrix mat, return the number of submatrices that have all ones. So we'll use the concept of dynamic programming to solve this problem. So let's take this sample test case and let's define TP of ij as number of submatrices of length, not length, of height 1 that we can form with I comma j as the bottom right. So what's this value? Since we have fixed height, right, we are just forming subarrays basically. So for each row we'll calculate the consecutive ones, or basically subarrays of ones, that we can form ending at I comma j, or ending at the jth column. Basically we have to do it for every row, right? So let's try doing this for sample test case. So this will be 1 0 1. The second row will look like 1 2 0, right? Third row will look like 1 2 0, right? Now once we have done this, we can try to extend the heights, right? We fixed it to 1 initially, but we can form more submatrices by trying to extend. So let's try to iterate over all ij, right? So this is 1, so there's nothing above, so just add this to result 0, and similarly there's nothing possible for this one, right? So just add it here. Now comes this second row. So there's one possible width, right? We can form this submatrix ending at 1 comma 0 and starting at that point also, right? Ending and starting at the same point 1 comma 0. So we can form this one, but if we try to increase the height, so let's try to see what width is possible from this. So basically what we'll see is, while going up and trying to increase the heights, we will be bottlenecked by the minimum height, right? So if this was 2 and if this was 1, then if we had to extend using this point, we can only reach a width of 1, even though from this below point we could have reached a width of 2. So we are always constrained by the minimum width. So anyways, like we were at this point, so we could form this submatrix starting and ending at 1 comma 0, and we can extend this to form this 2 cross 1 submatrix. So add this, right? Now we are at 2, so we can form two submatrices of height 1. Now let's try to see what width is possible from this above height, right? So 0 width is possible, so we can't extend this, right? Now this is a 0, so we don't need to add anything. So this is a 1, right? We can form one submatrix of height 1. Then we see what width is possible from this height. So we can basically extend this to form this 2 cross 1. Then we see what width is possible from this height. Again we can extend this to form this 3 cross 1 submatrix, right? Now we come to this point. So we can form two submatrices of height 1. Now let's try to go to height above this, right? So we can form two width. We can go to max width 2, right, from this point. So basically what we can do now is, the earlier two submatrices, this 2 and this 1 and 2, right? So this submatrix just consisting of this two, we can extend this to form 2 cross 2, 2 cross 1 submatrix now. And this submatrix that we could form earlier, we can extend this to form this 2 cross 2 submatrix now. So we just add this new width value, right? Then also while going above, we'll keep taking the minimum of widths possible, right? Because we are always constrained by the minimum, and whenever we reach 0, we can stop iterating. Although in this sample test case, it wasn't needed, but anyways, like we can just sum this. 4 plus 3 is 7 plus 2 is 9 plus 4 is 13, which is what is returned here, right? So let's try to code this approach up. So let's say m is the number of rows, n is the number of columns, so this will be mat 0. Then we can first pre-compute the maximum subarray lengths for each row, right? So we can say I in range m and for j in range, and we can say tp is equals to, first let's initialize to be filled with zeros, right? So we can say that if mat of I j is 1, then we can say tp of I j is equals to dp of I j minus 1 plus 1 if j minus 1 is greater than or equals to 0, else we can just say 1, right? Starting and ending here. Now once we have done this pre-computation, we can again do the same loop. And we can define a result variable which we will return in the end, right? So before returning, let's say if dp of ij, that is at least one width is possible, right? Then what we can do is we can loop over k, right? For k in range, what height, right? The top corner, where does the top corner lie on in which row? So it will go till 0, and we can say w is equals to min of, okay, w is equals to, we can set dp of ij, initial height, and sorry, initial width, my bad. And this will we'll keep updating dp of kj, right? And if w is 0, we can just break, and we can just add this w every time, right? So let's try to run this code now. Okay. So as you can see, we are passing the sample test cases. So let's try to submit the solution now. So as you can see, we have passed all the test cases. So thanks for watching.